All right, let's talk about LPG storage safety. Today, we're diving into the technology that's changing the game, preventing overfills and controlling emergencies before they even start. It's really all about transforming a standard tank into a smart, self-protecting asset. So, where do things usually go wrong? When we picture an incident, our minds often jump to a major tank failure. But is that really the root cause? Is that where the chain of events truly begins? Well, it turns out most accidents don't start with the tank itself. They almost always start right here during the filling process. We're talking about a bad level reading, an alarm that fails, or maybe one that just isn't acted on fast enough. This moment, right here, is the weak link. So the modern solution tackles this problem head-on by making the tank smart. And this whole approach is really built on 4 key pillars of protection. Let's walk through them. First up, and this is non-negotiable, is pillar number 1, accurate level measurement. Everything, and I mean everything in a safety system depends on getting this one thing right. It's the foundation for everything else we're about to discuss. For years, we relied on traditional mechanical gauges. The problem is, they can drift, they need a ton of maintenance, and they're just not built for the tough conditions inside an LPG tank. But modern radar technology, it's a whole different story. It's stable, it's incredibly accurate, and it's designed from the ground up for pressurized LPG. And let's be really clear about this. If your basic level measurement is off, then every alarm, every automated shutdown that depends on that data, well, it's all built on a shaky foundation. You have to have a source of data you can trust, period. Okay, so once you have that rock-solid data, what do you do with it? That brings us to pillar 2, using that data for automated overfill prevention. This is our first active layer of defense. It's a really smart, layered approach. First, you get a high-level alarm. That's your heads up. But if the level keeps rising, the system doesn't wait for a person to react. It automatically triggers a high shutdown and closes the fill valve. And for the most critical sites, you can use what's called voted logic, which means multiple separate sensors have to agree before a shutdown happens. It's incredibly reliable. Now, this isn't just some system you cobble together. These automated safety systems are engineered to meet really strict standards. They get what's called a safety integrity level, or SIL rating. Think of it as a guarantee. A SIL 2 or SIL 3 rating means the system's reliability has been proven for the most critical jobs out there. Which leads us right into our third pillar. I mean, it's great to have an automated safety system, but how do you know for sure it'll work when you need it? That's where remote proof testing comes in. This really gets to the heart of it. We're moving past just ticking a box on a maintenance form. We're moving towards creating safety barriers that you can actually prove are working, on demand. It's about verification, not just paperwork. And the real game changer here is that you can test the entire safety loop, from the sensor to the valve, without taking the tank out of service. You can do these crucial checks more often, with way less disruption. It's a massive practical advantage. And that brings us to our fourth and final pillar, the Emergency Shutdown System, or ESD. Now, this is designed to handle a completely different kind of problem. Here's the simplest way to think about it. The overfill prevention system we just talked about, that's to stop too much product from getting in. The ESD system is designed to stop product from getting out when something goes wrong during a transfer. So, picture this. A transfer hose ruptures, or a truck accidentally pulls away from the loading rack. You need to stop that flow, and you need to stop it instantly. That is exactly what an ESD valve is for. Fast, immediate isolation. Okay, so the technology makes sense, the 4 pillars are clear, but how does a real-world facility actually put this into practice? Let's switch gears from the what to the how with a straightforward action plan. You don't have to do everything at once. The key is to start small. Pick one vessel and run a pilot. You'll upgrade the level technology, add the automated shutdown logic, figure out your proof testing, and check the ESD system. But maybe the most important step, training your operators on this new way of thinking, where automation is the primary line of defense. And if you take one thing away from all this, let it be this. Just having an alarm isn't good enough anymore. We have to move past relying on a human to hear a horn and react in time. The whole philosophy has to shift so that automated logic becomes the primary safety barrier we depend on. Because at the end of the day, the future of LPG safety isn't about thicker steel walls. It's about having a smart system, one that's accurately measured, can be proven to work and automatically acts to keep your people and your facility protected.